How do I know if I'm recording?
I think it's recording now.
It beeped, but it doesn't give me that little, where's the little, I did too, but there's, usually it gives us this little box in the corner that says you're recording. Yeah. I don't even know how to stop it. It's not showing me anything. What do I do?
You hit enter. I said left foot.
Oh wait, it is. Okay, we're good. That'll be fun for anybody watching the video in the beginning. Okay. Oh, it's backwards. It's not my Chromebook. That's why this is. I forgot it at home, and I've never forgotten it. All right, here we go. It is. All right, so here's the deal. The one thing that I feel, well, not the one thing, a couple things make the division hard. Number one is knowing when to do what division. When do I split it? When do I not have to split it? So basically, the first division, one term divided by one term. Just straight up divide. Numbers, x's, y's, z's, subtract your exponents, put them back in the bigger one once. Then we saw if you had more than one term divided by one term, you could split that. Now we're going to be dividing by more than one term. So we're not going to be allowed to split. So when you are taking a few things and dividing by one term, you're allowed to split that, and it won't affect the answer. But guys, if it was the reverse, the minute you try to divide by more than one term, you can't split that. It doesn't equal the same thing if you tried to split it. So you're not allowed to split when you divide by more than one term. That's how you're going to know this is a long division problem. You're going to be dividing by more than one term. All right, so I figured that it might be better to practice long division with numbers first before we bring in the variables and the exponents and make them really, really big. So guys, let's just remember how we long divide numbers first. Long division says you're supposed to divide, then you multiply, then you subtract, then you bring down, and you repeat the whole process. So let's try it with numbers. If I asked you what's 174 divided by 6, you're trying to figure out how many times 6 can go into 174. So let's set it up. How many times can 6 go into 174? Does that look familiar? Yeah. Okay. So Nora, you start by dividing. So you say to yourself, how many times can 6, the first piece, go into the first number 1? How many times? 0. Can't. So then we go to the next place value, and we say, how many times can 6 go into 17? 2 times without going over. So above the 7, because that's the place value we're at, you put a 2. That's the division step. Then whatever you put up here, you multiply with the front. So what's 2 times 6? 12. That's divide, multiply, now we subtract. So what's left over? What's 17 minus 12? 5. Then you bring down the next place value and you do it again. So now we're trying to find out how many times does 6 go into 54?
29.
Not 29, that's the answer. 9 times. So now above your 4, you put the 9. Whatever you put up here, you multiply. What is 9 times 6? 54. Now we subtract to see what's left over. What's 54 minus 54? 0. Is there anything left to bring down? So you're done. Is anybody know what we call the 0 or whatever number is left down there? The quotient is our answer. That's 29. What do we call 0? Starts with an R. He's your remainder. So 0 as your remainder is the best case scenario. It means nothing was left over. It means that 6 divided evenly into 174, and it divided in 29 times. So that's your answer. So 174 divided by 6 is 29. 29 would be the answer you type into Delta Math. And then you can check it by saying this. What you divided by 6 times your answer, because multiplication should put division back together, should equal who you are dividing into, 174. And it does. All right, let's try another one. Let's try long division again. Oh, yeah, right here. All right, so now what if I asked you, what's 2,116 divided by 4? Let's see. How many times can 4 go into 2,116? So we divide, first. How many times can 4 go into 2? Can't. So we go to the next place value. How many times can 4 go into 21? 5 times. So above that first one, put your 5. Keep yourself organized and in line. What is 5 times 4? 20. Now we subtract to see what's left over. What's 21 minus 20? 1. Bring down the next number, and we do it again. Now how many times can 4 go into 11? 2 times. So now above that second one, you put a 2. Now we multiply it in. What is 2 times 4? 8. Now we subtract to see how many are left over. What's 11 minus 8? 3. Bring down the next number, and we do it again. Now you're trying to find out how many times can 4 go into 36. 9 times. So put a 9 above your 6, and now you multiply them in. What is 9 times 4? 36. You subtract to see what's left over. What's left over? 0. Anything left to bring down. So he's your remainder, and he's the best one. That means that there is no remainder and that everything divided evenly in. So what's the answer to 2,116 divided by 4? 529. That's what you would say is the answer to that problem. Now, if you wanted to check it, you could say 4, who you divided by, times your answer, 529. That should get you back to who you divided into, 2,116, and it does. Okay, I'm going to skip number 3. I don't think we need a third example. I want to get to the variables. However, I do want to do, you did it good. So I do want to do number 4 with you because you should know the answer kind of already off the top of your head. I need you guys to see what happens when you do get a remainder. So I can try to explain how we write a remainder with numbers first to try and make it make sense. Because guys, I'm going to tell you right now, when you get a remainder, when we're long dividing polynomials, the remainder looks weird. It is. It doesn't look pretty. So let me try to explain it with numbers first so that hopefully it makes a little bit of sense. All right, so really quick. If I asked you guys what's 34 divided by 8, first of all, guys, is 34 going to divide evenly by 8? No, right? We know 8 times nothing gets us 34. So we know there's going to be a remainder. So let's just see what happens. All right. First, we would say, how many times can 8 go into 3? It can. How many times can 8 go into 34 without going over? Duh, 4 times. Sorry, 4 times. 4 times 8 is? 32. What's left over? 2. Okay.
8.2.
There's no, you can't say 8.2. No. So is there anything left to bring down? No, so 2 is your leftover remainder. Does anybody remember in elementary school how you'd write your answer?
4R and then
R2, right? You'd all write 4, remainder 2, right? Everybody remembers that? It's garbage. Get rid of it.
what?
BD3. Yeah, hey, congrats! I saw the minutes. Good for you. Terrible for us. Yeah, no problem. I'll send them. Bye. Chris, they need you in the office real quick. Yes.
Can you put a 0?
No, that's right. No, you can put a 0, but we don't want decimals.
Keep doing that.
Decimals aren't going to help us with polynomials. We're going to need to use the remainder, but how do we write it correctly is what we need. All right? So, this is what we're going to do. You need a pass?
That's bad.
Passes. Here, Chris, I'm just going to sign it. You fill it out.
I said left foot.
Dude, if my son does that one more time, I'll show you the footage of him going to the dugout doing the, I won't even embarrass myself, but anyway, he's singing the song. It's pretty cute. All right, so here's the problem with the remainder. We don't want to write it like this. We need the remainder to be written as part of the answer. So at first, this is how you're usually taught to handle the remainder. If you wanted to put all this back together, you could say that who you divided by 8 times your answer of 4 plus add on your remainder of 2, and that should get you back to 34. Does that work? If I do 8 times my answer of 4, add in my remainder of 2, does it get me back to my 34?
Yeah.
Perfect, right? That's usually what you're taught originally to do with your remainder. Okay. The problem with polynomials is, guys, we don't want the remainder by himself. We want him to be written as part of the answer. I want him in here with the answer of 4. So then some students are like this, well then Marty,
6.
Do this. Put them inside with the 4. But here's the problem. If you do that, PEMDAS says to do inside first. What's 4 plus 2? 6 times 8 is not 34. So that doesn't work. So you can't write them just inside like that. It doesn't get you back to the 34. So here's how you have to swing it. If you want the 2 to be written as part of the answer, then you're going to do this. 8 times 4 plus. You're going to add on your remainder. But guys, think about it. He is 2 out of the 8 pieces that we were trying to divide in. So it's 2 over 8. You have to write the remainder over who you were dividing by, which was 8, and now that should get you back to the original answer. Because now watch this. Let's distribute. What's 8 times 4? 32. 8 times 2 over 8. Guys, what happens to the 8 on top and the 8 on bottom? And you're just left with plus 2. And now what's 32 plus 2? 34. So that's how you're going to have to write the remainder. You're going to put your remainder over who you divided by. So the way we would write this is not remainder 2. It would be 4 plus a remainder of 2 over 8. Okay, I know, you're going to miss it. But we need the polynomial, the answer we're going to get with these polynomials, we need the remainder to be written as part of the polynomial. So guys, I'm not going to lie. Whenever you get a remainder, it's going to look weird. You're going to have this beautiful polynomial, and then you're going to have plus 7 over x minus 2. It's not going to look pretty, but that's what happens when you get a remainder. You have to put it over who you divided by. All right, guys, at the end of the day, 4 plus 2 over 8 is 4 and 2/8. It's 4 and 1/4. It's 4.25. So now what's 8 times 4.25? Somebody ask your calculator, what's 8 times 4.25? It's 34. So it does work. That is the right answer, okay? All right, perfect.
Wait, so do you put the answer as the 8 and then parentheses 4 plus?
So this is your answer. No, this is your answer. I was just trying to show you why the answer is written like that. But whatever you put up here is your answer, okay? All right, let's do it. Let's do some long division of polynomials.
So that's without the x's and stuff.
This is without the x's. Now we're going to do it with variables.
Let's go.
All right, I like it. Let's do it.
I don't.
All right.
Keep it completely to yourself.
All right, so here we go. This is part 3. Part 1 was one term divided by one term. Part 2 was multiple terms divided by one term. We split it. Part 3 this is when you have to use long division. When you have a polynomial of more than one term divided by another polynomial of more than one term. When you divide by more than one term, you got to use long division. All right, so that's one reminder. Another little loophole you have to watch out for is you're going to have to look for missing terms. I'll try to explain that when we get there, okay? And then another thing, I actually want to add one more bullet. I want you guys to have this in writing. One of the worst steps when it comes to long dividing is the subtraction step. And students always seem to mess that part up, and I can understand why. So I want to put a reminder in writing for you right now. It's not going to mean anything to you now, but just write it down. I want you guys to remember that you're going to have to pick up the subtraction each time. Again, it means nothing now. Pick up the subtraction each time. I just want that in writing. Okay? All right, we're going to start with as easy as these problems are ever going to be. This is the easiest example I could start with.
What does that mean?
That it's only going to get harder from here.
No, the subtraction.
It will mean nothing. You'll see. I'm going to explain it when we get there.
Okay.
All right, here we go. So guys, look at example number 1. They want you to take a 1, 2, 3 term polynomial and divide it by how many terms? 2. If you divide by 2 terms, are you allowed to split this?
Yeah.
No! Only if you divide by 1 term can you split. So the minute you see 2 terms on bottom, this has to be long division. All right, so we're trying to figure out how many times can x minus 5 go into that polynomial. So let's get set up for long division. How many times can x minus 5 go into, pause. when I said you have to look for missing terms. The polynomial you are dividing into, x squared plus 3x minus 40. It's not allowed to be missing any terms. All polynomials are supposed to be written in standard form, descending order. So if it's an x squared, an x should come next, and then a number should come after that. If it starts with an x to the third, then an x squared should come next, then x should come after him, and a number should come last. You're supposed to have all of your terms accounted for. So let's pretend, for giggles, that this polynomial was just x squared minus 40. If it went from an x squared term to a minus 40, what term is it technically missing? The x's. And you'd have to fill in for that missing term. So when you wrote it here, you'd have to do this. X squared plus the 0 x's that this problem doesn't have. I didn't change the problem. It still doesn't have any x's. But I need a placeholder for the x's to go. All right, and then you would put minus 40. Because just because he doesn't have any x's in his polynomial doesn't mean our answer can't have an x in it. And we have to leave a place-holding spot for those x's to go. So it has to have all of its terms accounted for. So guys, if it starts with an x squared, make sure there's an x and a number. Otherwise, you're going to fill in a 0, okay? Some polynomials, it goes from an x to the third to a number. And now you're filling in a 0x squared and a 0x. That's fine. But you have to leave place holding spaces for these terms. All right? All right, well, lucky for us, this was not missing any, so we are good to start. Right out of the gate, I need you guys checking for missing terms. All right, so plus 3x minus 40. You ready? Here we go. Just like before, the first thing we did was we were like, how much times does 6 go into 1? It doesn't. How can 6 go into 17, all right? So to start this, you're going to start with the first term, which is x, and you're going to ask yourself, how many times can x go into his first term? No. So now listen to me. So now how many times can x go into x squared? Sometimes it's hard to think of it like that. So then I would do this. I would say to myself, how many times can x go into x squared? Division can always be turned into multiplication. So I would say x times what gets you x squared? Who's the missing piece? X. So that means x can go into x squared x times. That's the division step. So now to keep yourself organized, in your x column, give yourself an x up top, because when you divide, you put your answer up top. Okay, so that's what we do with the numbers. All right, so that was the division step. Now we have to multiply them in. So before, whatever we wrote up here, we multiplied with this. So we're going to multiply this with that, but we have to distribute it. All right, now again, everybody just soak this in. It's only the first one. What is x times x squared? Oh my God, what is x times x? X squared. Guys, these have to match. If the fronts don't match, you didn't pick the right guy up there, or you multiplied wrong. Something went wrong. The fronts have to match. All right, now take x and multiply them with -5. What's x times -5? -5x. So just keep going. You got your x squareds, now you got your x's. Just keep writing them in line. All right, so we divided, we multiplied, now we subtract. And you have to pick up the subtraction each time. So we're going to subtract. Now watch this. What happens to x squared subtract x squared? The fronts have to cancel. That's why we want the fronts to match. So they will cancel in the subtraction step. So they cancel. Beautiful. Now here's where stuff hits the fan usually. Students look at this, they're like, oh look, it's -2x's. No, it's not. Because you have to pick up the subtraction each time. This is a positive 3x, subtract a -5x. What happens to subtracting a -5? It turns to a plus. And now really, what's 3x plus 5x? 8x. Beautiful. All right, now we've done everything. We bring down and we repeat the whole process again. What's up? What'd you say? What'd you say? I missed it.
She got us doing.
Oh, guys, come on. This is nothing. This is nothing. This is just basic arithmetic here. And it's only the first example, so you're not allowed to get mad yet. You're not expected to just pick it up in the first example. We got to do a few to get into a rhythm. All right, now we do it again. So now we have to find out how many times does x go into 8x. So ask yourself this. X times what gets you 8x? Who's the missing piece? 8. And the good thing about this is if you stay organized, this was an x. The next thing that comes after an x is a number. It's probably a number that you need next. And we need an 8. So give yourself a positive 8 above your numbers. So we divided. Now we're going to multiply them in. What is positive 8 times positive x? 8x. The fronts have to match. If they don't match, you didn't pick the right guy or you didn't multiply right. What is positive 8 times negative 5? Negative 40. Now, the second piece does not have to match. Only the fronts have to match. This is a bonus. This is probably saying we're going to get remainder 0, but only the fronts have to match. All right, now we subtract to see what's left. What's 8x take away 8x's? The fronts have to cancel. That's why we want them to match. All right, now we got to pick up the subtraction. This is negative 40, subtract negative 40. What happens to minus a negative number? Turns to plus, and now what's negative 40 plus 40? They cancel, and you get 0. Anything left to bring down?
No.
So that's your remainder, which is the best possible remainder. And now what will you say the answer to x squared plus 3x minus 40 divided by x minus 5 is? X plus 8. That's what you would type into Delta Math. That's your answer. All right, shake it off a little bit. That's only the first one. You have to practice this to get the process down. All right?
Wait, so it can't be x 8? It has to be x plus 8?
Yeah, why wouldn't? What's x8?
So you can still pass if you failed this one.
What?
Yeah, I know that B and
Guys, you don't know how much you anger me when you're like, yeah, I just throw in the towel. This is doable. This is doable. I don't know what you guys expect. I have to teach you algebra 2. This is algebra 2. What do you want from me? I don't know what you want.
it's not you.
I have to teach this. You're expected. For 17 years, I've taught this to juniors in high school, and nobody put up such a fight as you guys on everything that I teach you. This is what you're expected to do. I'm sorry, but it is. The problem is none of you remember algebra 1, so now I'm expected to teach you algebra 1 and algebra 2. I have to teach this. This is the class you are enrolled in. All right, my temper tantrum's over. Here we go. So now we're going to look at the next one. We have to get into rhythm. It's the first one. We are taking 1, 2, 3, 4 terms and dividing it by how many? 2. Are you allowed to split this? No, you have to divide by 1 term in order for it to be a split. This is not. So this has to be long division. So we have to set ourselves up for how many times can x minus 4 go into? Pause. Look at the polynomial you are dividing into. We have to make sure that all of his terms are accounted for. He goes from an x to the third to an x squared to a just x to a just number. Is he missing any terms? No. So we're good. We don't got to fill in any zeros. We're good to go. So put them under. 2x to the third minus 13x squared plus 26x minus 24. Okay. We're going to divide. We're going to multiply. We're going to subtract. We're going to bring down, and we're going to repeat. So we start with division. First term into first term. How many times can x go into 2x to the third? So x times what gets you a 2x to the third? What number do you need? 2, and you need an x squared. Beautiful. So you need a 2x squared. So above your x squareds, that's where you should put them. It keeps you organized. All right, so we did the division step. Now we got to multiply them in. What is 2x squared times x? 2x to the fronts have to match. If they didn't match, you didn't pick the right guy or you didn't multiply right. The fronts have to match. All right, what is 2x squared times negative 4? Negative 8x squared. So just keep writing it. You're only multiplying him with two pieces, so it's only going to create two pieces. All right? And now we subtract to see what's left over, but we're going to pick up the subtraction each time. What's 2x to the third? Take away 2x to the third. Cancels. Fronts have to cancel. All right, this is where it's tricky. Students are like, all right, negative 21. Negative 13x squared, subtract negative 8. What happens when you subtract a negative 8? It turns into addition, and now what's negative 13 plus 8? Negative 5x squared. Now we bring down. Because this is polynomials and not numbers, I don't just bring down the next one, I just bring everything down so it's ready to go. Otherwise, you'll have like a term here and then one all the way up there. Just bring it all down. So plus 26x minus 24. Just bring everything behind it down. Because I have to find out how many times x goes into 2x to the third. It goes in 2x squared time. Here, think about it. If I have to do x into 2x to the third, what's 2x to the third divided by x? 2 divided by 1 is 2. Oh, over x to the third over x is x squared on top. That's when you divide them in. I don't make you think of it like division. I tell you to think of it as multiplication. X times what would have gotten you a 2x to the third. Okay? All right, here we go. So now we're starting over. How many times can x go into negative 5x squared? So guys, x times what gets you negative 5x squared? Negative 5x. So again, it looks like x's should be next. So now you need a negative 5x. So above your x's, put your negative 5x. All right, now you multiply them in. What's negative 5x times x? The fronts have to match. If they don't match, you didn't do something right. All right, what's negative 5x times negative 4? 20x. Remember, they don't have to match, only the fronts. All right, so now let's subtract to see what's left. Pick up that subtraction. This is a negative 5x squared, subtract negative 5. What happens to minus minus? Turns to plus, and then what do? Fronts have to cancel. That's why I want them to match. All right, here we go. Now this is where, I tell you to be careful. Students look at that and they're like, 46. No, it's not. This is 26 x's, subtract 20 x's. Guys, what's 26 subtract 20? It's 6, right? Because really, what's a negative and a positive going to become? A negative. So really, that's a minus 20x. What's 26 minus 20x? It's 6 x's. So be careful. Pick up the subtraction. You have to come back here and get that subtraction. All right, bring down the minus 24, and we're almost there. Now, guys, look. X squared, x. What should come next? A number. So it's probably a number that we're going to need to make this happen. How many times does x go into 6x? X times what gets you 6x? 6. So above your numbers, give yourself a positive 6. And the signs matter. If you need a positive 6, make sure you write plus 6. If you need a negative 6, make sure you put minus 6. All right, let's multiply it in. What is positive 6 times positive x? The fronts have to match. We want them to cancel. What is positive 6 times negative 4? Negative 24. Now, they did not have to match. If they didn't match, it doesn't mean you were wrong. It's a bonus when they do, okay? But they didn't have to. Only the fronts have to match. All right, let's subtract and see what's left. What's 6x? Take away 6 x's. Big 0. They cancel. Negative 24. Subtract negative 24. What happens to minusing a negative? Turns to a plus, and it cancels remainder 0. So what is the answer to this division problem?
2x squared minus 5x.
Perfect. That is what you would type in to Delta Math. Okay? Again, I will never say, I won't use the easy word for sure, but we can do this. It's going to take practice, and it's a process, but we can do this. All right, I'm going to try. I have 10 minutes. I'm going to do one more. I want you to see what happens when you get a remainder, and number 3 has a remainder. So let's see what we do with a remainder. Okay. Here we go.
Math makes my stomach.
No, math makes you feel good. All right, here we go. Look at what we have. It's not set up like a fraction, but who cares? Because we're going to put long division in place anyway. But look what we're doing. We're taking a 1, 2, 3-term polynomial, and we are dividing it by how many terms? 2. 1, 2. 2 terms. If you are dividing by 2 terms, can you do it as a split? No, this has to be long division. So let's get set up. How many times can 4x minus 1 go into, pause. Look at the polynomial you are dividing into. It goes from an 8x squared to an x to a number. Is he missing any terms? No, perfect. We don't got to fill any zeros in. So 8x squared plus 34x and then minus 1. Here we go. We're going to divide. We're going to multiply. We're going to subtract. We're going to bring down, and we're going to repeat. How many times can 4x go into 8x squared? 4x times what gets you an 8x squared? A 2x. So above your x's, give yourself a positive 2x. All right, now we multiply them in. What is 2x times 4x? 8x squared. The fronts have to match. All right, what is 2x times negative 1? Negative 2x. Now we subtract. Let's see what's left. What's 8x squared? Take away 8x squared. They cancel. Fronts have to cancel. All right, 34x's. Subtract negative 2. What happens to minus negative 2? Turns to plus, and you actually end up with 36x's. Beautiful. And then minus 1 comes down. Let's do it one last time. Guys, it looks like, what comes after an x? It looks like we're going to need a number last, all right? How many times can 4x go into 36x's? 9 times, right? 4x times what gets you 36x's? A 9. So we need a plus 9. So now put above your numbers, give yourself a plus 9. All right, let's multiply them in. What's positive 9 times 4x? 36x's. The fronts have to match. All right, what's positive 9 times negative 1? Negative 9. Second ones don't have to match. It's a bonus if they do, but they don't have to. It doesn't make you wrong. It just means you're probably going to have a remainder. All right, so now we subtract. What's 36x subtract 36x? Fronts have to cancel. Negative 1 subtract negative 9 turns to plus, and you get 8. Do you have anything left to bring down? So that's your remainder. And again, you have to be able to write them as part of that polynomial. So you're going to go to your polynomial, and you're going to say plus a remainder of who? 8 over, who did you divide by? 4x minus 1. So as weird as that looks, this is what you would type in to Delta Math as your answer. But please make sure only the 8 is over 4x minus 1. The 2x plus 9 is not. They're not over anything other than a 1. But only the remainder goes over 4x minus 1. Okay, go ahead.
Why do they have geometry with separate stuff?
That's true.
Because they'll tell you there are some geometry skills that you need for algebra 2. But again, in math's defense, everything you learn in algebra 1, you are expected to remember 1 or 2 years later.
That's a lot of time.
It is a lot of time. All right, so listen, I put a homework on Delta Math. It is 3 questions. It's due tomorrow like normal, but I would try to practice this as soon as possible. Now, guys, let me say this. I think you probably feel a little bit better when you get a remainder of 0 because it just makes you feel like you did it right. So I only picked problems tonight, I only picked a level of problems where you get a remainder of 0. So this way, when you first practice tonight, you should always get a remainder of 0, so you'll feel like you're doing it right, okay? So you're doing 3 problems. By tomorrow night, I would try to do this tonight to practice it. It makes tomorrow easier. But like I said, everything should get a remainder of 0. I hope nothing got stuck by me. Okay?